Have you ever stared at a square root and just felt completely stuck? You're not alone. Today, we're going to demystify them. We're going to turn those messy-looking radicals into clean, simple answers. Trust me, it's a core algebra skill you're about to lock down.
So let's just dive right in with our main challenge for today, the square root of 450. I know, it looks a bit intimidating, right? But the truth is, there's a super simple, kind of elegant method to clean this thing up. We're going to break that method down. And I promise, by the end of this, a problem like this will be a total piece of cake.
So here's our game plan. First, we'll get into why this even matters. Then, I'm going to give you the only two rules you really need to know. From there, we'll build our core strategy, walk through some examples together, and then wrap it all up with a few pro tips that will make this skill stick for good.
Okay, so first up, why even bother doing this? Well, it's all about clarity. Think of it like tidying up a messy room. A simplified radical is just cleaner. It's organized, it's easier to read, and it makes every single calculation you have to do later on that much simpler.
The entire goal here comes down to one simple idea: finding any perfect squares that are hiding inside the number under the radical and just pulling them out. And if you need a quick reminder, a perfect square is just a number times itself. You know, like 9, which is 3 times 3, or 25, which is 5 times 5.
Now, every job needs the right set of tools, right? Well, for simplifying radicals, your toolkit is surprisingly small. There are really only two fundamental rules you need to have in your back pocket, and they will unlock pretty much every problem you're ever going to face.
And here they are. The product rule lets you take one multiplication problem under a radical and split it into two separate, easier ones. And the quotient rule, it does the exact same thing, but for division. That's it. These two rules are the absolute foundation of everything we're about to do. So, with those two rules in our toolkit, we can now build out our main strategy. This is the how-to part. This is how we actually find and remove those pesky hidden perfect squares.
So, how do you know when you're actually done? What's the finish line here? Well, a radical is considered fully simplified when that number inside, it's called the radicand, by the way, has no more perfect square factors hiding inside it. Not even one.
I like to think of this whole process as a kind of puzzle, or maybe a treasure hunt. Your mission is to hunt for the single biggest perfect square that divides your number evenly. And I really want to stress the word largest here, because finding that one is the absolute key to solving these problems in one clean step.
And this right here, this is the pro tip that makes all the difference in the world. Finding that largest perfect square factor right from the get-go saves you so much time and effort. It stops you from having to simplify and then simplify again. It's just the fastest, most direct path to the final answer.
All right, enough theory. It's time to put our toolkit and our strategy into practice. Let's get our hands dirty and walk through a few examples together, step by step.
Let's start with a classic, the square root of 72. You'll see this number pop up all the time. So, applying our strategy, what's the very first step? That's right, we're going on a hunt for the largest perfect square factor.
So what is the biggest perfect square that divides evenly into 72? You might think of 4, or maybe 9, and those do work. But the biggest one, the real prize, is 36. So we're going to rewrite the square root of 72 as the square root of 36 times 2. Okay, now it's time to pull out our favorite tool, the product rule. This lets us split that one problem into two separate little pieces, the square root of 36 times the square root of 2. See what we did there? We've isolated the part we can actually solve. And for the final step, the magic trick. We solved the part we can. The square root of 36 is, of course, 6. So the 6 gets to escape from under the radical sign, leaving the poor little 2 behind. And there it is, our clean, simplified answer, 6 root 2.
Okay, so what about a fraction, like the square root of 75 over 4? Don't panic, it's the same idea. Our first move is to use the quotient rule. We split this into two smaller problems, the square root of 75 on top and the square root of 4 on the bottom. Now we just simplify each part. The denominator is a gift. The square root of 4 is just 2. Easy. For the numerator, we hunt for the perfect square inside 75, which is 25. That simplifies down to 5 root 3. Finally, we just put it all back together to get our answer. 5 root 3 all over 2.
You've totally got the core strategy down now. So let's wrap this up with a few final tips that are going to help you solve these problems even faster and with way more confidence. Think of this as your success checklist.
Okay, this table right here, this is your secret weapon for speed. Seriously.
That hunting step we talked about becomes instantaneous if you know these perfect squares by heart. I strongly recommend memorizing these up to at least 15 squared. It will make a massive difference in how fast you can solve these.
So, let's recap everything with one final checklist. 1. Memorize those perfect squares. It's a game changer. 2. Always hunt for the largest factor first. 3. When you think you're done, give your answer a quick double check. Make sure no other squares are still hiding in there. And of course, remember your two fundamental tools, the product and quotient rules.
Hey, remember that messy problem from the very beginning, the square root of 450? Well, the answer is 15 root 2. But you know what's way more important? You now have the strategy to simplify any square root they throw at you. You've turned a confusing problem into a clear set of steps. So, with this skill officially unlocked, what's the next algebra challenge you're ready to take on?